I've got a log here from Nepalien, um, and I want to start out by thanking you, Nepalien, for giving me some relatively easy questions and an opportunity to look smart. When I first started doing this, I was a medium fish in a in a big pond, and I hoped to help out the smaller fishes, if you will, the people who knew even less about PID tuning than I do. And somehow along the line, people got the idea that I knew what I was talking about, and now I am getting a lot of much harder questions to which I just don't know the answers. And so thank you. I hope that I'll be able to help you out here. Um, we have a ZMR 250 Emax 12 amp ESCs, loop time 2000, gyro cut of 60, P term cut of 40, D term cut of 12. All of this seems pretty nominal. This is a little bit on the more filtered end of things, but my opinion is more filtered is going to give you a, maybe it's going to give you a little bit softer flying copter, but especially as a beginner, that's probably not a bad thing. You're probably not going to be going, wow, this doesn't feel really locked in while you're, doing laps around your yard or something. So maybe there will be opportunity to sharpen up the response in the future, but for now, this seems like a safe way to probably not get you into trouble, but maybe not have the most responsive copter. I also see that you're using PID controller 1, so am I. Boo, Lux Float, ew. No, I'm just kidding. Uh, I tune PID controller 1 and I like it. Maybe after I do my rebuild, I'll go to Lux Float like everybody has gone. Since after I do my rebuild, I'm probably gonna retune from scratch anyway. So, well, maybe. Um, you are on. You don't say whether you're on 3S or 4S. I see from your log you're on 3S. I Your p-values just starting off. Your p-values look a little low. We'll have to see whether the log bears that out. For perspective, I'm running not a dissimilar setup, and I'm at like 5 or 6 on my p-values. I'm running a 1500, so I'm a little heavier than you. Um, I also can't help but notice, your battery is a zippy 1000 milliamp hour 40C, and that works out 40 times 1 amp hour is 40 amps. It's easy math, 40 times 1. You're at 40 amps, and you're running 2200 kV motors on 5040 props. I don't know what that's pulling off the top of my head. Presumably you're under 12 amps. I mean, I'm running 2300 kV motors with 6-inch props, 60/30s, and I pull about 35 amps at max, if my memory's correct. That being said, I usually like to give my batteries a little more headroom than that. So if your battery is rated for 40 amps, I would be comfortable pulling 20 or 25 amps. The thing is, it's not a hard line. The closer you get to the C rating of the battery, the more your voltage is going to sag. And the more your voltage sags, the shorter your flights are going to be and the less punch you're going to have at the end of the battery. So if you plan to pull 40 amps and you buy a battery that has a C rating that gives you 40 amps, you're not going to be happy past the 50% mark roughly. I mean, I'm making that number up, but you're not going to be happy. So I like to, if I can, maybe even, if I'm going to be pulling 30 amps, I'd love a battery that could give me 60 amps. I mean, I'm not going to go buy a $50 battery like like a spec, like a racer. Uh, but I'm going to, I want a little headroom on my battery. So I don't think that's going to, affect your tuning at all. I just wanted to point that out, that as you continue to grow as a pilot and a builder and a tuner, that you might want to consider upping your game on the batteries a little bit, and you'll be happier. You'll get longer flights, and or you'll get flights where at the last 25 or 35% of the battery, you're not just sort of hovering around because you're afraid of doing anything aggressive because you won't have the power to pull out. So let's have a look at your logs. And in your, I did sync up your log here. And let's just take a look at what you're doing. So we can see that there's a little bit of bobble at the end of that stick movement. That is clearly something that needs to get tuned out. Let's just go back and see it again at half speed for anybody who is watching. And we can count also. Let's look at the gyros here, and we can see as the gyro trace goes up, that's the beginning of the move. As the gyro trace comes down, the move is slowing down and ending. Here is your bounce back and your oscillation, and we can see there's 2 to 3 oscillations, right? So we definitely want to do something about that. As long as we're here, let's take a look at your noise. Oh, very nice. So your copter is your gyro traces are relatively thin. Your copter is relatively filtered. As you get into more advanced tuning and more demanding, as you become more demanding of the copter's performance, you may want to consider raising those numbers, raising your gyro cut a little bit, maybe raising your D-term cut. For the time being, I think we could probably get a pretty good tune without having to tweak those from where they are now. So what I'd like to do is I'd like to look now at your roll, and specifically let's do the setup I like to do. Yeah, let's do that. So we'll do RC command roll and gyro roll, and we'll do gyro plus PID roll, and we'll take a look at what's going on there. So just to recap, I've said this many times in many videos, we can see RC command go up, commanding, I think that's left roll, is it? Is that left? No, it's right. Well, okay, that's right roll. There you go. RC command goes above the axis, that's commanding right roll. You can always just cross-check with the stick if you, like me, don't remember perfectly. As it goes up, the P term goes up, which forces the gyro to go up. Notice that if we add the gyro here, I'm just going to put it on the bottom graph as well. Notice that the gyro lags the P term. So that the P term rises and the gyro rises. And I want you to, in fact, let me take that out. Let me take RC command out for now. And I'm even going to zoom in a little bit. I want you to look at the amount of time between when the P term starts to rise and when the gyro starts to rise. And in fact, let's just get the D term out of there as well. Let's just keep this, and get the I term out of there. Let's just keep this real simple. The P term begins to rise at 7.631, and the gyro goes up. I mean, I don't know, it reaches its max around 7.7. It doesn't really start to go up until 7.6, 7.63, 7.6667. I guess what I'm getting at is that the P term rises sharply, but you can see that the gyro, it just meanders along. It doesn't respond sharply like the P term does. And what this is indicative of to me is that there's probably your P gains are low. And I kind of said that at the beginning of the video. So I'm not going to be able to give you a hard rule for how much space there needs to be between the P term and the gyro. But in general, you want the gyro to be pretty responsive to the P term. If you're yanking the copter all around, then the gyro may have a hard time keeping up. By that, what I mean is that the gyro is responding to what the motors are doing. So if you're yanking the copter all around, the motors are going to be, the PID loop is going to drive the motors and the gyro will report what the copter is doing. The motors may not be able to change directions and change speeds fast enough to make the gyro completely match the P term exactly. But in this case, you haven't done anything too radical. You've just done a little 45-degree twitch to the side. And so we really should see the gyro being more sort of coincident with the P term instead of the sort of meandering its way up. Oh, I guess I finally got there. 7.7 seconds. We should really see the gyro rising and the trace more closely matching the P term, at least at the beginning of the move. Now, we want to be careful here because notice that the P term now drops, right? And what that's telling us is that the P term, the RC command went above the axis, the P term went above the axis, and the gyro went above the axis. They all went positive above this axis. And that means they're all pushing in the same direction, and the gyro is moving in that direction. Now we see the P term go below the axis, which means that the P term is now trying to slow the copter down. The gyro is above the axis. So the P term is pulling back on the gyro now, saying, okay, you're going fast enough, slow down, don't go too much faster. Now, it's okay that the gyro doesn't just sort of drop off, right? What the P term is trying to do is hold the gyro where it is. And it's only when, let me get RC command in here. It's only when RC command goes back to 0 that we then want to see the gyro drop off to 0 again. So we can also add some perspective by looking at RC command. Notice that the gyro being smooth, being slow to rise like this, we can also see when we look with RC command that you didn't exactly jam the stick whoop, hard to the side. You moved it relatively leisurely, and that to some degree explains what the reason why it's slow to rise here. But I still think I'm going to stick with my conclusion that your P gains are low, in part because I'm familiar with the general expectations of the parameters, and a P gain of around 3.5 is probably, I just feel like it's probably low. It may seem counterintuitive. I mean, when we think of high P gain, we think of oscillations, and it may seem counterintuitive that low P gain can also cause oscillations. But the thing is that the P gain is the strength of the correction. And so if the strength of the correction is too low, you'll get kind of a sloshy response. And if we watch this, oh, I've got it going way too fast. Have I? No, zoom out. And playback speed of 100. Let me just... So there's a little bit of an oscillation there, but it's not a hard and fast oscillation. It's a relatively soft oscillation, and I would say that that is probably a low P gain. Also, there's only one or two. If it was harder and faster, and especially if there was more than one or two, then I would say that that is probably that would be higher P gain, excess P gain. So I would suggest raising your P gain to, let's say you put them at 5. Put them both at 5. Now my expectation would be that especially if you don't have a C mix, a custom motor mix, which you gave me your log. I can see if you do. Hang on. No, you're using Mixer Quad-X. So I would not expect your pitch and your roll P gains to be the same. I would expect your pitch P gain to be higher than your roll P gain. In fact, your roll P gain may be about right at 3.5 or 4. But try raising at least, well, no, because we're just looking at roll. Sorry, gotta keep up with myself here. We're looking at roll, and I think it's low. So yeah, definitely then raise roll. Try putting both pitch and roll at 5 and see if that induces oscillations, and then work them down. And then your D gain, where are you at with D? 20 and 24. That is probably, if you've got soft filters, that can probably come up to 30 or 40 once you get your P a little closer to right. All right. Good luck and happy flying.